Thank you very much. I'm Tina Huang, co-founder and CTO of Transposit, where we build an API composition platform. And I don't see the clicker here. Thank you. There we go. I've been working with APIs for a very long time. First building really old school APIs as part of the application framework at Apple, and then building both applications and backend infrastructure at places like Twitter and Google. So it should come as no surprise to all of you that businesses are constantly looking for ways to improve their efficiency through automation. You know, having people do lots of manual tasks is terrible. On top of just all the time it takes to do the individual tasks, there's a ton of overhead that gets incurred. You have tickets to track what tasks need to be done. You have workflows to manage all of the handoffs. And then you have to manage the inevitable delays that will happen for each one of these handoffs. And on top of that, there's a ton of human error that can happen. Mistyped characters, wrong hits of buttons. And so we're constantly looking for ways that we can have computers automate these processes for us. This not only improves our business efficiency, but it oftentimes leads to much better end results. So companies are adopting more and more SaaS every day. And unfortunately, with all of this new SaaS, there's an increasing demand for automation. It's great because we now have all of these specialized apps to manage various parts of our business. But at the junctures between all of these applications, most often means manual workflows. People having to do tasks from one application and then switch it over to another. And for each application, that oftentimes also means different users. Even for a specific user, if it's the same user on both applications, different SaaS applications had different identities on each of the applications. So again, this means usually it looks like a human has to go in and take the output from one application and manually enter it into another. And so we have this increased demand for automation with all of these SaaS. But luckily, SaaS providers are increasingly becoming aware that they need to empower all of the users of their platforms with APIs. APIs, they really give you this power to automate. APIs allow you to programmatically call all of these different applications, which enables you to turn all of these manual workflows into automated ones. The need for automation, it increases exponentially the more applications you have to work with. Unfortunately, current automation is really focused on a very small subset. That is, things that can be fully automated. So this tooling, it focuses on things that have concrete, discrete triggers and then workflows that can be fully completed without any sort of human intervention. This unfortunately limits you to the types of workflows that you can actually automate. And on top of that, because there's no room for human intervention, all configuration, it needs to be done a priori. So take, for example, a very basic type of automation. So we're mostly developers here. And when someone commits a change to your code base, you probably want to trigger a build in your CI/CD pipeline. And maybe even go so far as, if that build fails, file a Jira ticket for you to track the changes. But even for this very, very simple workflow, you have to do all of this upfront configuration. You might need to specify what Jira component do I want to file this ticket under. And maybe you want some sort of algorithm to determine who I should assign this to. And the same goes for priority. Depending on the complexity of the workflow, this sort of configuration can actually be pretty tedious. And the challenges around this kind of automation, they just get worse once you factor in the class of tasks that require individuals to provide and identify different APIs. So in these cases, Each user has to specify and configure the workflow themselves so that they can provide their own user credentials. So let's take a look again at that previous example. So if we make this minor change where instead we want to allow the developer to file that JIRA as themselves, that tiny change now means that you can no longer set up this workflow one time for all of the developers within your organization, but suddenly every developer has to set it up for themselves so that they can auth JIRA for you. So now we've introduced this new complexity, which is how do we communicate to every person the proper way to configure this workflow? So how can we get some of these efficiencies of automation into more and more of our workflows? Fortunately, there's something that's called human-in-the-loop automation. Human-in-the-loop automation is automation, but at various points along the way, you give humans the opportunity to intervene and influence the direction of the workflow. So let's take a common case where a customer signs up for your product, and you want that to automatically create a new record in your marketing system. But let's say you want to annotate that marketing record with information about the referral source. Unfortunately, systems of record are often inexact matches. So if you were to fully automate this system, you'd probably end up with either inaccurate results or missing results, or very likely a really complex data cleansing problem to deal with later. With human-in-the-loop automation, you can instead imagine a different type of workflow. Instead, you notify the marketing team when a customer signs up for your product. And you let the automation gather the appropriate data. Like maybe it gives you a set of approximate matches to present to the team members. Now the team member can have an efficient, streamlined process with which to select the appropriate referral sources before resuming the workflow. With human-in-the-loop automation, rather than think about it as man being replaced by machine, it's really about letting a person do the tasks that they are very good at and letting machines do the rest. So now that we have some understanding of what human-in-the-loop automation is and some of the reasons we might like to use it, I'd like to walk through a few different patterns for what this kind of automation and workflow look like. The most basic form is letting the human act as a trigger. I like to think of this as the free pizza button. So let's imagine that you are a customer service rep for a pizza delivery service. Oftentimes, the best thing for you to do is when a customer complains, give them a free pizza. Unfortunately, this can actually be pretty tedious for the customer service rep. They might need to create a coupon code and then file a report tracking the customer's complaint. So instead, why don't we have some sort of automation that lets the customer service rep do the part that they can add value, which is determining who should get the free pizza, and then give them a streamlined one-click button to actually do that tedious process for them. Another common pattern is you actually have a discrete trigger for that event, but you want to have a human actually determine the next best course of action. So let's take that example of developer builds again. Developer builds can oftentimes be flaky. They can fail for these transient reasons like network connectivity issues. But it'd be pretty inefficient if every time the build failed, you automatically retry. I know a lot of builds can take up to 30 minutes or an hour to build. So a hybrid approach might look like you notify the developer that the build has failed, but you automate the gathering of all of this data so that they don't have to do it. So maybe present them with the build logs, as well as inline buttons to quickly and efficiently act. So now, instead of a developer seeing the notification, maybe that a build failed in Slack, having to go to their CI/CD system, dig through a bunch of logs, find the correct build, and then go to somewhere else to either revert the change or continue the build, they can maybe now efficiently do all of that from within one place. And finally, machines aren't perfect. Sometimes what you really want is the ability for a human to do a final sanity check to reduce embarrassing errors. At Transposit, we use Google Hire as our applicant tracking system. Google Hire has this handy email templating system that lets you email your candidates, and it automatically substitutes in the name from the resume. This has unfortunately led to cases where I've emailed candidates with a name in all caps, which is pretty embarrassing, I have to say. But when I instead do this process by myself and hand construct the emails, I often end up in cases where I forget to provide the candidate with useful and important data. So what I really want is a system that lets the computer do all of that email templating for me, but then gives me the opportunity to intervene as that final sanity check. So what we're really talking about here is building applications that really enable business automation. There's a whole class of workflows that event and triggered full automation works for, but for all of the rest, we need applications. Applications provide the interfaces that allow us to pull in humans at these critical junctures. And what makes this class of applications unique is they're really about integrating and composing applications through APIs. Our jobs as developers is increasingly about building applications to improve workflow efficiency. And building these applications is increasingly about plugging together various APIs. But connecting and combining APIs rarely looks like that clean Lego block picture. APIs unlock a ton of possibilities, but in practice, they're a real pain to work with. Each API seems to be its own unique snowflake. Who here has spent more time than they really care to admit to digging through some nitty-gritty API documentation just to get the thing to work? Yeah, pretty much everyone here, right? That's because APIs often reflect how the service owner is thinking about their data and their data infrastructure rather than how you as a consumer want to use those APIs. For example, how the service has chosen to cache or index their data, that often dictates what APIs are even available to you. One common manifestation of this problem is what we call the N+1 problem. So that's when what really should be a single API request to fetch a series of results accidentally becomes N+1 requests because you have to do a follow-up call to get more data for each one of those results that gets returned. And another example of this is pagination. We often talk about pagination as if it's one mechanism. You know, fetch some results and get, to fetch 100 results, you fetch 25 and then the next and the next. But in practice, pagination is a bunch of different mechanisms. One of the most incredible examples that I've seen is the Slack API. Slack has 5 different pagination mechanisms all sitting side by side for the single service. And who wants to guess how they might try to solve this problem? That's right. They'll probably introduce a 6th pagination mechanism, one to rule them all. This same lack of standardization, it also affects authentication, but at least here we're getting some sort of consolidation with OAuth 2. Unfortunately, there's still a ton of legacy auth out there, and even for OAuth 2, there's a ton of variation between implementations. So by the time you're done as an API consumer thinking about all of these different pieces, your code probably looks like a convoluted mess. But this complexity is way worse than just the complexity that you have within a single application. And that's because we're talking about the complexity of interactions between applications that all have to communicate over the network. And that effectively means that all application developers in this new API ecosystem have to have some understanding of not just distributed systems, but also security. At Transposit, we call this problem of having to glue together all of these different APIs the problem of API composition. And the reason we think that this is such an important problem is because the number of APIs, they just keep on increasing over time. And unfortunately, the complexity of composing on top of all of these APIs, it scales exponentially the more APIs you try to compose. And then on top of the complexities of composing APIs, as I mentioned before, each SaaS application has its own concept of identity. And so that means that if you want to build on top of them, you need to now be able to link together all of these different identities so that you can properly authenticate all of the various underlying API calls. So let's take a quick moment to recap. We know that as developers, we need to be able to pull together all of these different tools, and that these tools, they empower us with these powerful APIs. But each API has its own unique steep learning curve. And what we'd really like is to be able to operate at some higher level of abstraction, not think about all of the mechanics of talking to those APIs, but instead just be able to think about what my intent is, what data I like to retrieve, rather than the mechanism of how to do that. And critical to being able to do that is to pull away all of this nitty-gritty of API composition, of auth and pagination and retry logic, and pull that out of the code and into that platform. To do this, we need to give developers a higher level language or interface to talk to that can abstract away those pieces. At Transposit, we do this both with SQL and a JavaScript API. But for the next few slides, I'm going to show you SQL because I think it really does a good job of exemplifying what I mean here. So take this simple select statement. The developer's intent is just, here's an API, give me a list of items. But even this very simple select statement actually buries a ton of mechanics. It includes, how do I authenticate? Do I need to sign this API request? How do I think about reauth? What's the HTTP method that I want to call? Is that parameter a header parameter, a path parameter, a query parameter? And then you add something very, very simple like limit. And now we can bury away all of that mechanism around pagination. And we've already talked about how pagination is really a bunch of different mechanisms. So here, you call list items, and now you don't have to think about the fact that you're really pulling that cursor out, calling another call, and on and on. And then they're trying to connect together multiple APIs together. The developer, all they really want to think about is, this is the data I like to retrieve, and here's how I like to combine the two together. And so this join statement can now be turned into something that calls an initial request, pulls out that item ID, does a series of parallel follow-up requests, and then figures out how to merge those results. And even authentication can be abstracted away. So here I have two different handles that represent my personal identity versus my work identity. And as a developer, I now just have to think about which identity I'm trying to join on and not have to think about the mechanism of what credential do I want to fetch and how do I properly apply that to various APIs. And in practice, your code probably looks more like this convoluted mess. And here, I haven't even done any optimization around parallelizing requests or thinking about futures or doing any sort of error handling. Aside from the pains of actually writing this code, there's also challenges in maintenance of it. So here, having a higher level language for abstraction not only makes it easier to write your code, but makes it easier for someone else to come in, understand the intent, maintain that code, and hopefully reuse it for other purposes. So now I'd like to walk through a few examples of some automation that we built at Transposit that includes human in the loop. The first one I'd like to talk through is what we call where's my commit. So at Transposit, we have this multi-tiered release process. So developer commits a change, it goes to a developer build. Once a day, we cut a branch that goes and gets deployed to our staging environment. And then after a 24-hour bake period, that now gets pushed to production. When I'm wearing my product manager hat, I often want to know, this Jira, where is it? Can I check it in demo or staging? And when can I tell a customer that it's ready in production? So this process used to involve me pinging an engineer who would then go from the Jira, grab the Git SHA, dig through ECS tasks to figure out when this will be deployed, and then send me a message back. And so one of my developers wrote this Slack command for me called where's my commit. And now I can just type where's my commit, give it a Jira SHA, it aggregates all its data, and tells me when I can expect it. And we've walked through this example already with CI/CD systems and developer builds, but I'd like to go through a more concrete example. So at Transposit, we use Circle CI as our system, but unfortunately, the default Circle CI integration is pretty weak. All it allows you to do is configure a channel and notify you of success and failures. So we've enhanced this with buttons to inline retrieve artifacts and then retry a build or revert a change. And then we've added to it on success to call Postman and run a set of monitors to tell us how our build is doing. And once again, we have an easy inline way to rerun the monitors if we see some sort of abnormal behavior. And if it seems really bad, then we can revert the build all from within Slack. And finally, there's DevOps on-call processes. At Transposit, we manage on-call through a Slack channel, as I'm sure a bunch of you probably do. And so an alert, when it fires, it goes to Slack. And oftentimes, different team members from engineering or SRE will sit in Slack and collaborate. But one of the common problems is, how do I make sure everyone is talking and seeing the same dashboards? So we've written a slash command that you can type in an alert name, and it actually pulls the CloudWatch graph inline into the discussion. And then on top of that, we've made it easy so that you can quickly file a Jira to track that incident. But once again, we allow the human to intervene and give it some additional information. We've published the Slack Postman example for you to play with, so please come check it out. And I'm out of time. So once again, I'm here from Transposit. We are free to try, so please sign up. Thank you very much.